Hi, my name is Siowling. I'm currently working at the National University of Singapore. I believe at that point of time, I was a curious kid and was simply wondering about how the world works and asking a lot of questions. As a child, I was a hyperactive kid. I had many different wishes every other day. One of the wishes is to become a scientist after reading about great scientists like Albert Einstein. Since I'm in research right now, I guess one out of the many wishes did come true. Our research involves the elimination of static charge. The generation of static charge is a very common phenomenon. Whenever two surfaces come into contact, they usually accumulate a lot of static charge. One surface will be charged positively, and another surface will be charged negatively. And this brings about an attractive force between the surfaces, and that results in many common phenomena that we see. On the other hand, the generation of static charge brings about a lot of undesirable consequences in our daily lives. For example, the electric shock that a person experiences whenever he or she touches a doorknob in dry weather, for example. It can bring also about the sticking of many substances with each other, for example, dried clothing or small objects onto each other, and including dust particles. Not just the annoyances in our daily lives, it can also bring about many hazards in industry. For example, it can serve as the ignition source for explosions. It can cause damage to electronics. It can also cause fouling of particles onto the pipes and vessels in industry. And it has undesirable consequences in a wide range of industries, including petrochemical, chemical, pharmaceutical, food, semiconductor, electronics, and packaging. Because of this wide-ranging effects that static charge has on our daily life and the wide range of industry, is actually a very big wall to break. The common method right now for overcoming this problem is to use conductive materials. But this method is not effective because many products just cannot be made conductive. For example, food particles or drug particles for human consumption, they cannot be made conductive. And for this kind of insulating materials, whenever they come into contact with another surface, even for conductive surface, the contact brings about charge onto this insulating material, and therefore charge still remains on the insulating material, and the problem still remains. So the ideal solution really is if we have a method where insulating materials come together and come into contact without generating charge. That will really be the ideal solution. And our research is about that. Our research involves a fundamentally novel approach. So instead of using conductive materials, we fabricate non-charging materials that are not necessarily conductive. For example, they can be polymers that are completely insulating. When we use our non-charging material and brings it into contact with another material, both surfaces generate equal amounts of positive and negative charge. So in other words, there is no net static charge generated on the surfaces. In this case, the insulating materials will be able to naturally resist the generation of static charge, and therefore will be able to solve problems related to static charge in our daily lives and in industry. Our method is general. It's not just for one type of non-charging material, but it is for a general class of customizable non-charging materials. Results have always shown that powders tend to stick very much onto the surfaces of stainless steel and onto polymeric surfaces. But when we coat the stainless steel using our non-charging material, or if we use the non-charging polymer, we see that the powder no longer stick onto these surfaces. Electronic components also tend to stick very badly onto their own packaging material. But when we use our non-charging material, we see that the electronic chips tend to sit very nicely in their compartments and no longer stick onto the non-charging material. Expensive protein powder is also known to stick very badly onto commonly used laboratory tubes. But when the tube is now coated with our non-charging material, we see that the expensive protein powder no longer sticks onto this tube. We believe that our fundamental technology can bring about a wide range of benefits to the society. For example, we are now currently reaching out to a wide range of industries and providing solutions to their static problems. There are currently a number of anti-static products being marketed, but we believe that the unique capabilities of our technology can be better than existing products. For example, we do not need grounding, and our materials are not just limited to conductive materials, but can also involve insulating materials. With these unique capabilities, we believe that we will be able to provide more solutions and more commercializable products. Basically, what is static charge? So despite being a very old field and research has been going on for many decades, even in this current era of research, not much is known about static charge generated by contact electrification. The most important question is, what is the molecular species of static charge? And also, what is the mechanism by which static charge is generated by contact electrification? Upon hearing about our technology, my friends usually are excited and they usually provide a lot of ideas. For example, can we now make anti-static combs?